Hi, my name's Steve, and I work in engineering at Elastic, and I'm the tech lead of the machine learning team. And what I'd like to talk about briefly today are the machine learning and statistics features we have in the Elastic Stack and how you can use them to understand your observability data and your IT systems better. The first thing is that there's a sort of a term which is AIOps, which is widely used in this space to describe some of the technologies I'm going to talk about. And this term is a Gartner term that stands for Artificial Intelligence for IT Operations and describes product features such as being able to detect and predict signals from all the data you're collecting, effectively looking at the root cause of these signals, automatically or easily, and potentially even automatically remediating issues as well. And these features sound great, and they're sort of similar to some of the autonomic computing type features that we've that have been around for a long time. But really, what I want to talk about is Elastic's view on these features and the types of things that we're concretely putting into the stack now, and the observability solution as well. So the first thing is we're not trying to add artificial intelligence just for the sake of it. We're focusing on features that will add value to real practitioners. So that be our customers, the users of the observability solution. We also have a large internal observability team managing our internal systems, and our support team as well. And the way that we think about observability is it's really about understanding systems, about measuring and explaining systems. And that doesn't need necessarily artificial intelligence. I mean, there are cases where machine learning technologies can help, but often things like being able to search across data in a high dimensional way, being able to apply statistics where appropriate to the data to try and understand things like latency, can give you insight into data and actually help you understand the behavior of your real systems. So, a lot of this boils down to the fact that, we're a search company, and we're for search. And a lot of what we're trying to do is use search to help you understand your systems. Now, a challenge is that in observability, the searches aren't as straightforward as they are when you're searching text by keyword. So, for instance, I might want to search a large number of metrics to see if any of them have changed. Or I might, if some of them have changed, I might want to know why. So, for instance, if there's been an increase in log rate, I might want to understand why that's changed. And similarly, I might want to understand if I've got an application, what is dominating the tail of the transactions, what's slowing down the majority of the transactions here. And to actually get the answers to the searches and get a set of good relevant results, you often need to analyze the data in a statistical manner or even apply statistical models to try and get the results. And these are some of the things that I'm going to be talking about and how we're approaching this problem. So the first thing I'm going to talk about is this search to explain latency, which is a sort of a very common problem in APM. So, the first thing is, we need to visualize the data properly. And here I've got a log histogram on the right-hand side of the latency distribution for a particular service. And you can see that these latency distributions aren't just simple Gaussians. They're multimodal. And often if you're in charge of an application, what you want to understand is what is influencing the different modes of the latency distribution here, and in particular what's dominating the tail of the latency distribution, which are really the slow transactions which have the biggest impact on your users. So, here's the data in our app, and really, the goal here is trying to understand, what are the most influential field values that cause slow transactions? Is it a particular user? Is it because people are coming in from a mobile device? Is it part of my application? And what's going on here? And this is not easily searched for, because it involves understanding statistically what is shifting the distribution to that tail. And here are some examples. If I look at a particular endpoint, we can see that the orders endpoint in this particular example, it sort of dominates the tail compared to anything else. And so if we were like developing an application or debugging an application, that may be a good place for us to start in terms of speeding up the overall user latency for this application. But it's non-trivial to find out that it's that endpoint, because I've got a large number of fields, and those fields have a large number of distinct values. And so this is really sort of a high dimensional search, and we can search across this manually, manually using sort of the conventional product. But really what we're looking to do is to provide tools to help you perform these type of searches in a more automated and rigorous manner. Okay, so I'm going to go into a demo of our product now to show you how we can do this. And here I've got our APM tool. And I'm going to go into the front-end service of our APM tool. And then I'm going to go into a particular transaction, which is a create order transaction. You can see that this transaction has had some failures, and here's the latency distribution of this particular transaction. And if I look at a sort of a typical transaction here, we can see that there's various tags or labels associated with it. So in this case, the shipping country was France. The order price was high, and the order range was large. You can see different attributes like the client and the user ID and so on. And in this case, what I'd like to do is sort of like go across all these fields and the different values here to try and understand, well, what's the stuff going on in the tail here. Now, I can select things here, I can click, I can manually sort of do a whack-a-mole process to try and determine that. But it'd be good if there was some way of statistically rigorously doing that. And that's what we've done here in latency correlations. So here we're actually iterating over all those fields. We're iterating over a candidate set of variables that we can select and reduce the search space, and we come out with a set of results which sort of dominate the tail. And as you can see, as we overlay them on the latency distribution, they are the ones which sort of dominate there. And this is something that we've automatically worked out for you. And this is a way of us using statistics. It's not artificial intelligence, but in this case, we've used statistics to try and help you understand your APM data and understand your application better by automatically running this type of statistical investigation in the background to give you these insights. Okay, now I'm going to go to sort of a slightly larger example, which is sort of very, very relevant to us. And this is actually how we manage and how we observe our internal systems. Internally we have a lot of cloud deployments, and often we use the Elastic Stack for a lot of purposes internally, whether it be development or business or support and so on. And these are critical business systems to us, and so we want to observe these and manage these in an appropriate way. So these deployments, we actually send all the logging and metrics data to particular clusters, and from there we can actually use the observability product and Kibana to actually help us understand this data. And so this is the example I'm going to be using of some of the internal, a large internal system that we're running internally, and how we can use observability to determine what's going on and why. So, a challenge here, like a lot of your systems as well, is that you get a large fire hose of logs. In this case, on some of our larger regions and deployments, we actually have sort of 15 terabytes of data a day coming into there, which consists of logs and metrics and so on, which is a large amount of data, and it can be difficult trying to get insights into this data to understand exactly what's going on. So, one strategy that we use, and that we sort of recommend that the customers use as well, is that we define some high-level SLIs, which sort of track how the actual user experience of using this platform. So, for instance, sort of a classic SLI to use is success rate, which is really sort of the number of good events sort of successful interactions a customer has over the total number of interactions. So, for instance, if I've looked at a web page 100 times, did it work 100 times, or did it work 99 times, and so on. And based on these service level indicators, I get a good idea about the overall health of my application. And I can also set objectives on those. And these objectives can be static thresholds I might want to define, or these objectives could be things that we use anomaly detection or other things to detect change. And really, in this case, we're defining these SLIs, and then we're using elastic observability to understand change, and then why those changes have been happening in the underlying system. So, here's a chart of sort of a real SLI of one of our systems, and we can see that sort of around midnight at this time, it dropped significantly to 94%. And sort of a key thing is, well, why did it drop? And that's where potentially we can use sort of search to detect change to try and actually help us understand, what changed when it dropped and what was related to it. And the first thing I'm going to do here is actually run anomaly detection on the constituent parts of the SLI. So in this case, we have a success rate and a failed rate. So here, if I run anomaly detection in the app on the failed rate, I can see that there's an anomaly at this point. If I run this anomaly detection on the SLI and the constituent parts here, I can see I get this nice swim lane, which shows that at this particular point, I had a drop in the SLI, and that was actually due to an increase in the failed events. And at that particular point, the success events didn't change significantly. So here, we can use anomaly detection to actually detect change and then pull together those changes into this correlated view to help us understand what's going on. And we can also use anomaly detection to do and the forecasting capability based on the models we've used for anomaly detection to help us understand what the potential future number of requests are, and potentially the capacity of our system. Okay, so we've now potentially got these anomaly detection technologies to help us detect a change. But really what I want to do now is say, well, why has that changed? I've got an increase in error rate. Why has that happened? And really, sort of these probable root causes are the focus of the rest of the presentation. So in this case, zooming in, I can see that at this particular point, there's been a significant increase in errors and a significant increase in the log rate at this time. And if I look at one of these errors, if I look at one of these, this is sort of like looking at this in Discover. Often trying to diagnose this problem is a bit of again sort of a whack-a-mole type thing, where I might look at, well, what was it? Is it because there's a particular action or a particular user? Was it, did this all come from a particular cluster or a particular region, and so on? And you sort of can go through this in a sort of a manual brute force manner and try and understand, well, what was related to this increase. And based on what we've seen in the way that users interact with the systems, we thought, well, would it be good? It would be good to actually try and automate that in a similar way to we did to explain latency, to help you understand things like log rate changes and other changes in your system. So in this case, if we actually look at the data across different dimensions, we can see that actually enterprise search was responsible for this. The enterprise search was responsible for a significant part of this increase, and things like the zone and other things didn't really change relative to each other as the error increases. And what we can do, we can actually do statistical tests to actually help us understand what the biggest influences are. In this case, we can actually see that enterprise search was a big influencer and other things aren't, and we can also plot this in different ways. We can plot this according to the orange is sort of like at this change, and the blue is before that, and so on. And we can clearly see which fields had the biggest influence on these rate increases. And sort of pulling that all together, here we can see that in this particular case, it was this particular enterprise search cluster that was responsible for the log rate change. And that's great, because we've already got some good insights into, I've had this drop in SLI that could be caused by a large number of different things, but we've actually used anomaly detection, which is ongoing, running in real time to say this is actually an anomaly in the error rate. And we've then used we've then used these influencer calculations, sort of as we're investigating the change, to understand that the change in error rate is significantly influenced by the enterprise search, this particular enterprise search cluster, and that's great. So we're moving through the investigation. The tools that we're building into the Elasticsearch, into the Elastic observability solution can help you surface this information. But what next, and why are these things happening? And if you look at sort of the manual process, it's often there searching in and related logs. So in this case, because we knew it was an enterprise search cluster, we'll search we're searching these logs, and we're searching associated metrics as well. Okay, so the great thing about that type of analysis we did before in terms of looking for influences, we can actually also apply to things like, well, what enterprise search logs were relevant as well. Here are the enterprise search logs, and again you can see there's a large number of fields, but in this case, there's something which is even worse, is that there's unstructured text. And unstructured text is always difficult to deal with, because you can't simply aggregate it, because it can have different attributes and fields in there, and unique things like IDs and timestamps and all sorts of things. So how do we deal with that? And the good thing is we can actually use machine learning technologies to do this and to cluster the data into different things. Now, this is a technology we've had in the product, in the anomaly detection product, for a while now, but this is a technology that we're building out and making it a sort of a native power play in the Elastic Stack as well, where we can categorize the data. So in this case, I'm just running this categorization aggregation across, and you can see that it's grouping key terms in the log messages. So if I look at log messages, I've got these quite messy messages. I've got these quite messy messages here, but what I can do is I can take the key terms in these messages and I can group them, and I can understand sort of overall what these messages are. And the great thing is once I've done this, I've effectively got category IDs that I can treat in a similar way that I did with the other counts. And what I can do is I can then plot this. So here's the data as I see it in Discover, and here's the data. Here's the data that as I'd see it if I actually ran categorization on it. And you can see here straight away that there's a particular type, these orange type of messages that increase significantly at that time. And it's actually this particular set of messages. You can see that if I take them out, that spike goes away. When I put them in, you can see that that's sort of responsible for the count. So this is sort of like another way of us adding in more context to what's going on behind the scenes here. Overall here, we can see that we had a drop in SLI, we had an increase in the anomaly rate, and we had a change in the error rate, which was significantly influenced by the enterprise search on a specific cluster. We can then correlate that to a significant increase in requests, latency, and errors for this particular cluster. And we can also see there's a specific type of log message that was on the enterprise search cluster at that point. And then we can see that there was saturation of CPU of this cluster, which was sort of like the root cause of these problems. So overall, there were too many requests coming into the enterprise search cluster. It became saturated, and it started rejecting those requests, and that was the responsibility for the drop in SLI. And this whole holistic view is something that we're looking to pull together in the observability solution and the tools that we provide in the Elastic Stack to allow you to easily pull together this holistic view without sort of whack-a-mole searching across all sorts of fields. And the ability to detect change, the ability to understand why a change occurred, they're all features and tools that we're looking to put into the Elastic Stack to help you understand your data. And some of these are statistical features, some of these machine learning features, but it's really looking at the most appropriate feature for that particular use case to help you get from a change to its probable root cause. Thank you.